Determine the limit as x approaches positive infinity and as x approaches negative infinity of x times sine of 1 over x squared. Starting with the limit as x approaches positive infinity of x times sine of 1 over x squared, the first thing to do is try plugging a positive infinity in for each of the x's. That will give a positive infinity times the sine of, and 1 over x squared will go to 0 as x approaches positive infinity, so it'll be the sine of 0. The sine of 0 is 0, and the result is positive infinity times 0. We have the infinity times 0 indeterminate form here. We will need to rework this. Since the 0 is resulting from a sine of 0, we can make use of the identity limit as theta goes to 0 of sine of theta divided by theta equals to 1. Theta is the phase of the sine function. It must be going to 0, and it is here. We need to phase match in the other position. The sine's in the numerator, so we'll phase match in the denominator. So we have the limit as x approaches positive infinity of x times, we will isolate the sine, and we will now phase match in the other position by putting a 1 over x squared in the denominator. We can compensate this by putting a 1 over x squared in the numerator. In the numerator, one of the x's can cancel from the numerator with one of the x's in the denominator. Leaving a 1 over x, and sine of 1 over x squared over 1 over x squared. 1 over x squared does go to 0 as x approaches positive infinity, and it is phase matched, so it follows the identity, and that will limit to a 1. We can now plug a positive infinity in for any remaining x's. We have a 1 over x. As x approaches positive infinity, 1 over x will go to 0, and the result is 0 times 1, which is equal to 0. Now to work out the limit as x approaches negative infinity of x times the sine of 1 over x squared. The first thing to do is plug a negative infinity in for each of the x's, which will give a negative infinity times the sine of 1 over x squared goes to 0 as x approaches negative infinity, so it will be sine of 0. The sine of 0 is 0. The result is negative infinity times 0. We have the infinity times 0 indeterminate form here. We will need to rework this. Since it's resulting from a sine of 0, making the 0, we can make use of the same identity. We will isolate the sine so that it can be phase matched in the other position. In the denominator, we will put a 1 over x squared to phase match it. We can compensate by multiplying by 1 over x squared in the numerator. One of the x's again can cancel. Leaving a 1 over x times the sine of 1 over x squared over 1 over x squared. 1 over x squared does go to 0 as x approaches negative infinity, and it is phase matched, so it follows the identity, and that will limit to a 1. We can now plug in negative infinity in for any remaining x's. 1 over x will go to 0 as x approaches negative infinity. The result is 0 times 1, which is equal to 0. And there's the results for the two different limits.